Hello, hello, hello. Milky Mango, hello. Sorry, I had to pee. How's everyone doing? You had a math test today? How'd it go? What was it about? Nice, congrats. What am I doing? Right. So I was actually sleepy, but then I ate. So my plan was to just get this done as soon as I could. It was about limits and derivatives and all that. I'm in pre-calc right now, so we're just getting started. Okay, nice. Limits and derivatives. So calculus, but you're in pre-calc. Interesting. Yeah, so today's speed run. And then Max, my mod, actually has a lot of alternate Minecraft accounts. So he's gonna set me up with one. So Minecraft, I don't know when, but it will be sooner rather than later. Yeah. So IB exams, hey, next week. You ready, Snakestar? Why is she excited? Because Max is setting me up with a Minecraft. Awesome. So here's the first question of the 2017 paper one. And look at this, good old Venn diagram. So almost everyone should be able to answer this. You killed it? Nice. So let's see what we got. We've got a group of 20 girls. Nice. 13 take history, 8 take economics, 3 girls take both. Okay, easy peasy. So history has 13 people, so that means that P should be the other 10. And then economics, how much is it? 8? So this is 5. And then 10 plus 3 plus 5 is 18, which means that out of all 20, there should be 2 that are taking neither. So I think I just found out P and Q just by filling it out. And then girl is going to be selected at random. Find the probability that she takes economics, but not history. Well, that's easy. That's 5 out of 20. Yeah. And then, again, my YouTube channel, people would like me to check the answers as soon as I do them. So I'm gonna do that. Oh my gosh, okay. So 10, 2, I think that's correct, right? 10 and 2, yeah. And then this is something that I noted to my kids, and that this is to save you time. You don't have to reduce fractions for probability questions. Notice that they give you both answers, and both are completely valid. So yeah, okay, you could have reduced it, but you know, time is precious. So just leave it as 5 over 20. Yeah, save yourself the time. Okay, what's next? Okay, some functions. We got f, we got g. Let's find f inverse. Well, okay, so y equals 5x, which means that, wow, that's an easy inverse. X is essentially y divided by 5, and then of course we just change the notation. So x over 5. Nice. I mean, it just makes sense for probability because, like, you know, this is out of 20 people. So it makes more sense to say 5 people out of 20 than it is to say a quarter of the people. Okay, what's next? Composition. We want to find f of g of 7. So essentially, we're trying to find this. I don't know why I put outer brackets, but whatever. This notation here? Yeah. That's why I always write it as this. Hey Tofu Char. What'd you think of that movie, huh? Yesterday. Pretty good, pretty good. So f is 5 times x, and then x is now g, so that's a something squared plus 1. And then our x value is actually 7, so as you can see, there's the g, and then here's the f. Yeah, CG wasn't that great, but what can you do? Oh, tell her I say hello too. Okay, what is this? 49 plus 1 is 50, times 5 is 250. Easy peasy. Oh, by the way, Serpent. If tomorrow is sunny, should we play spike ball? Okay, x over 5, yeah? 250. Easy peasy. Look at how generous they are with the times here. This one is 6 minutes, and this one is 5 minutes. Both of these should not take you that long. And oftentimes for these like 6 question ones at the beginning of the exam, they shouldn't take as long as they say that they will. Especially if you know what you're doing. Okay, so we have this non-right triangle with 30, 45, and 13, and we need to find PR. So this length right here. So given this setup, we have a side with its corresponding angle. We have an angle, and we're trying to find its corresponding side. This is the exact setup for sine law. So in other words, x over sine of 30 should be equal to 13 over sine of 45. And I know that this is a paper 1, so you can't have a calculator, but please, before you start doing trig questions, make sure your calculator's in the right mode. Otherwise you're gonna get screwed. This is degrees. Okay, so what does this mean? That means, I'll just write it over here. X is sine 30 times 13 over sine 45. And these are ratios that you should know. Sine 30 is 1/2. Sine 45 is 1 over root 2. And then we just need to, you know, make this look a little bit nicer. So here's x, 13 root 2 over 2. Check my answer. See, 13 root 2 over 2. Easy peasy. Man, I think 2017 got an easy exam, at least so far. This is what I'm seeing. Okay. Jim heated up a liquid. He measured the temperature in degrees t minutes after it boils. See, look at this. They give you a mark to just write down what's the independent variable in this. The independent variable is obviously time. Write down the boiling temperature of the liquid. So he heated this up until it boiled. He measured the temperature of the liquid as it cooled. So that means that this initial temperature is the boiling temperature. Yeah, I hope it's easy for your guys' sake. Otherwise, that's just not fair. I've heard from looking at that IB subreddit, the boundaries might be a little bit skewed because the only countries still taking the exams are like the Asian ones. Okay, what's next? We can model the linear regression, but we're not actually going to do it because this is a paper 1. And then Jim describes this relationship as very strong. So which Pearson's correlation coefficient fits the best? Very strong is somewhere in the close to ones. So it's either negative or positive. Now, to determine whether or not it's negative or positive depends on whether or not your correlation is increasing or decreasing. So as time goes on, your temperature is cooling off. So that's a decreasing correlation. So we should be choosing the negative one. Yeah, thank goodness we're not in the same time zone as them. Yeah, negative high. And then here is his model. Use his model to predict the decrease in temperature for every 2-minute interval. Okay, so actually, you know, you don't even need to. This is a linear relationship, and you can see that this is the rate of change right here. This is the slope. Every minute, the temperature is going to decrease by 2.24, so every 2 minutes should be negative 4.48. Yeah. Yeah, okay. Easy peasy. Check my answer. So T is independent, boiling temperature is 105. Why do they have, oh yeah. You guys, I don't know if you can see it, but there's a negative there. And then valid approach, take the derivative. Are you serious right now? Just multiply it by 2. 4.48. Oh, I wonder if they would be picky about this. Because it says decrease, so your decrease should be technically, you know, a positive number. I wonder if they'll care. It doesn't say negative, so I don't know if they would be that strict. How do you show work for this one? You don't need to. This one is 2 marks. There's 1 mark for the method and 1 mark for the answer. But anytime there's a mark in brackets, that means that you can get this mark by showing you got the right answer. You don't have to show your work for this question. It's basically saying like if you got this answer, then it's kind of implied that you did the right method. Okay, what do we have? So we got an integral question. So this is, you know, x times some other function of x. As an SL student, you don't have that many options. This is essentially, it has to be a u sub. So what we're going to do is if we u sub the x squared plus 1, or sorry, minus 1, then the du is going to be 2x dx. And then this is nice because that x can show up right there. But anyways, okay, so that means that if I just move that 2 over, we can substitute the x and the dx in this integrand with 1/2 du. So this just becomes 1/2 e to the power of u du. And then that's easy enough to do because the integral of e is itself. And then don't forget your plus c. And of course, make sure you resubstitute. And then here's your indefinite integral. Okay, now, what's next? Find the function given that the derivative is this. And then f of -1 is 3. Okay, so if the derivative is this, then this is the antiderivative, which essentially, you know, for intents and purposes is the same as the integral. So this is actually our function here. And then we want to find the actual function, so we need to find c. And then that's why they tell us this information. So we're going to plug in the x value. Oh, this is -1. And we know that this should equal 3. Okay, this is 1, -1 is 0, so then e to the power 0 is just 1. So 1/2 plus c needs to be 3. I guess I'll just write that out. Which implies that c has to be whatever this is, 2.5, which is 5/2. And let's just actually answer the question. That means that our function is 1/2 e to the x squared minus 1 plus 5/2. Easy. So here it is, indefinite integral, blah, 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 blah. Right here, 2.5, 5/2, same thing. Nice. And then another calculus question. Okay, so here's a graph of the derivative of a function. Now, what does it say? This graph has maximum here. Sure. Minimum here. And then it also goes through this point. Sure. Okay. Then this point is on the actual function f. Okay. Then we need to write down the gradient of the curve of the function at p. So the gradient of the curve at p essentially means we need to find f prime at the x value 4, because that's the x value of the point. But luckily we have a graph of the derivative. So you see right here, the derivative has a value of -2 at the x value 4. So that's my gradient. And then find the equation of the normal to the curve at this point. So first we need the gradient of the normal. I guess I'll just call it m. And this is the negative reciprocal of the tangent gradient. So it should be +1/2. Now, we also know that the normal line, or the normal curve, the normal to the curve will also go through this coordinate, 4, 3. So we can get an equation from that. So y minus 3 should be equal to 1/2 x minus 4. This is just the point gradient form using this point and this gradient, and then it doesn't say what kind of specific equation it wants, so this is a valid equation and you can just leave it like that. And then determine the concavity of the graph when the functions between -4 and 5, and justify your answer. Okay, so concavity, right, is related to the second derivative. If this is positive, then we're concave up. I mean, I would leave it in this form. This is a valid representation of an equation. It's called point gradient form. I mean, if you really wanted to, you can multiply the 1/2 in and then move the 3 so that you get like a point intercept form, or intercept slope gradient intercept form. But I don't know. This is fine. And then what was I saying? And then if it's negative, you know that at that point it should be concave down. Now we have the graph of the derivative, and you can see from 4 to 5, right? It's increasing. So if I take the derivative of this graph, then it should have a positive derivative here. Because again, this graph is increasing. You can see more or less the slope is like positive. But because this is the first derivative, taking the derivative of this is the second derivative. So very clearly then, the second derivative has to be positive, so it's concave up. So your justification is something like this. The derivative is increasing on 4 to 5. Which basically means the second derivative is positive. So we are concave up. So check my answers now. Okay, so -2, yep. Gradient normal, 1/2. Oh yeah, so you see it's right here, snake star. They have it in the point gradient form, so it's an acceptable answer. And then correct answer with reasoning, graph is concave up. Sure, whatever. You just need to explain your reasoning. And this is valid reasoning. And then we move on to geometric sequences and series. For my class, when was that? Back in September? It's been a while. Oh, and look at this. It's geometric sequence and series with natural log. Okay, so what do we got? Find the common ratio. So common ratio you can always find by dividing two consecutive terms. So the common ratio is going to be natural log of x to the power of 8 divided by natural log of x to the power of 16. Log base e, not base 10. And then we can simplify this using log rules or log properties. We can take that 8 and then write it as a coefficient, and we can do the exact same thing with the 16. And then your natural log x's will cancel out. So here's your common ratio. It's a 8 over 16, which is 1/2. Then we're gonna solve this. I don't know if you guys can see it, but this is an infinite sum. There's infinity up here. So if you notice this thing, well, okay, let's just write this out, because a lot of people apparently have trouble with sigma notation. We're gonna start with k equals 1. So I plug in 1 for k. So what do I get? I get 2 to the power of 4 times natural log x. So that's my first term. Then I'm gonna add it with the next term, which is k is now 2. So now I plug in 2 in here. So then it becomes 2 to the power of 5 minus 2, which is 3. Natural log x. And then this keeps going on forever. 2 to the power of 4 is 16, by the way. 2 to the power of 3 is 8. And then, again, using your log properties, this is just a very fancy way of saying we're going to add up all the terms in this geometric sequence. Hey RGPT. And we know how to do that already, because we have an infinite sum formula. So this is the first term divided by 1 minus the common ratio. And we know what all of those things are. The first term is natural log 16. And then the common ratio is 1/2. So 1 minus 1/2 is 1/2. And then if we're dividing by 1/2, that's the same as multiplying by 2. And then we're going to use the log property again, and then multiply the 2 with the 16 in the exponent. So we have this. So here's our infinite sum. Now we know our infinite sum is equal to 64. So now that I know that this is equal to 64, then we can solve this equation. So this is saying that e to the power of 64 is equal to x to the power of 32. And then to solve for x, what's the best way to explain this? But essentially x needs to be e to the power of 2. Yeah, we're just gonna do some algebra. If we essentially divide this exponent by 32 and divide this exponent by 32, this is taking the 32nd root, essentially. Then you get x to the power of 1 is equal to e squared. And then you can just think about it, right? How do you get e64 if you have something to the power of 32? It needs to be e to the power of 2, right? Because 32 times 2 is 64. If you don't like doing it this way, then what you could have also done is, instead of using the property here to bring the 2 up here, we do it the other way. We bring the 16 down so that you will get 32 natural log x is equal to 64. And then solving for x, 64 divided by 32 is 2, and then you change this into the exponential expression, which is, this essentially says e to the power of 2 is equal to x. So either way, you get the same answer. Sure. It's the same thing, it doesn't matter. So let's check our answer. So common ratio is 1/2. Recognizing that the sum is infinite of our series, sure. using the formula, solving for x e to the power 2. So nice. Okay. Unfortunately, this one is no longer part of SL curriculum, vectors, so I'm going to skip it. And then we're going to go to this one. So we have a quadratic function, and then it's going to be written in factored form. So f has an axis of symmetry at 2.5, and it has a y-intercept at 0 and -6. And then we need to find the value of p. P is one of the x-intercepts. Our first x-intercept is 3. And since we know the axis of symmetry, then we can just reason out where the other x-intercept needs to be. So at 2.5 is the axis of symmetry. We know we have an x-intercept at 3, which means that your other x-intercept is on the other side of this axis, so it should be at 2. So p should be 2. And then we find the value of a. Well, a is now our only unknown variable, and we do know a coordinate on this, in this function. On this function? In this function, whatever. So essentially, I know that if I plug in 0, it should equal to 6, -6. So this is a times 0 minus 2 times 0 minus 3. This should equal to 6. And just going through the math, right? 2 times 3 is basically 6 already, so a has to be 1. Okay, and then this line is tangent to this curve at f. Find the values of k. Okay, so first off, let's write out f in its entirety, which is x minus 2, x minus 3. And we're probably going to take the derivative, so I don't like taking the derivative of using product rule when I don't have to. I'm just going to expand this out actually, because it's, in my opinion, easier to take a derivative of. Okay. Now, let's take the derivative of this, because the question was talking about tangents, so we'll probably need this. And then we have this. Okay, now, this is the line, y equals kx minus 5. This is in slope-intercept form. So I know that this graph, or this tangent line, needs to go through -5. So in other words, and then again, this line is tangent to this curve. So hold on, let me just reason this out a little bit more. This line is tangent to this curve, yeah? Find the values of k. You have a y-intercept at 0 and -6. How does that make any sense? Will we play Scriblio? I don't know, maybe. Or Garlic Phone? Ah, okay. Oh, this one is the one that, like, RGBT was yelling at me about. Okay, so here. you need to do two things. First off, you need to realize that this, right? That k is this expression because it's talking about tangent slopes. And then the second thing about tangent lines, the one that's often forgotten, is that they need to have the same y coordinate because, again, both graphs need to go through the same point. So in other words, this thing is k, and also y needs to be equal to the function as well. So these are the two requirements for a tangent line, right? The y coordinate of the tangent line needs to be the same as the actual function itself, and then the slope of the tangent line needs to be equal to the, well, literal derivative, which is the tangent slope. So what does this mean? This means that this, which was kx minus 5, needs to be equal to x squared minus 5x plus 6. And then we make a substitution here, and then we know that k is 2x minus 5. And you can see we have this equation. And this you can just solve for x, right? So first let's expand this out. This was a pretty tough question, to be honest. Okay, and then collect everything to one side, so x squared. And then the 5x's cancel, because they're the same. And then minus 6, so minus 11. Why is it k again? So k, right, is the slope of this line, or the gradient of this line. But this line is the tangent. So the gradient needs to be the derivative. So the derivative of f needs to be equal to k. And then we subtract 6, so you get 11. Actually, why did I move the 6 over? Doesn't matter. So this means that x is plus or minus the root of 11. And then we need to find the values of k. That's what the question was asking. So now that I know what x's are, I just plug them back into this formula that I had, where k is equal to the, derivative. So we have two values actually. We have 2 root 11 minus 5, and we also have negative 2 root 11 minus 5. Yeah, pretty tough question. So let's check and make sure that that's actually how you do it. Okay, so we skipped the vectors one. Okay, so as you can see, they basically do what I did. P is 2. And then you substitute 0 in for x and negative 6 in for the function. So blah, 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 blah. And then you get a is negative 1. Oh shoot, did I not write this right? Oh, I didn't write it right. It should be equal to negative 6. And I think I wrote 6. Oh shoot. Okay, so that should be negative, which means that that's negative. Which means that I have a negative here. So this should be negative, this should be positive. And that should be negative, so when I take the derivative, this should be negative, and that one should be positive. So time to fix this part of the question. Negative, positive, negative, positive. I thought this answer looked a little weird for a question 1, or a paper 1. Okay, so now, what do we got? I got 3x squared if I move it over to the right side, minus 10x plus 11 equals 0. Okay, and then we try to solve this quadratic. I think it's factorable. Three x, and then where should the things go? Is this even factorable, or is it not factorable? I don't think it's factorable. If it's not factorable, then we need to use quadratic formula. But let me just check and make sure that everything's in the right spots now. Oh wait, no it's not. Shoot. Because f is also changed. So it should be negative, positive, negative. So negative, positive, negative, negative, positive. Okay, so then moving everything to the right side, I'll get x squared. The what? The 5x's still cancel. Ah, okay. And then let's keep the negative 5 on this side. And then if we move the 6 over, you have negative 5 plus 6, which is 1. So x is plus or minus 1. Okay, and then, again, the question was to find k, and k should be equal to negative x plus 5. Yeah. So we have, essentially, 3 or 7 if you plug in positive and negative 1. So this looks nicer, and this is probably the right answer. Yeah, 3 and 7. Oh boy. This would be such a demoralizing last question. Check this out, Snake Star. We have a discrete random variable where your probabilities are trigonometric functions of theta as well. So here's a probability distribution table. Here are your probabilities of your random variable A. And then we need to show that cosine theta is going to be 3 over 4. So what can we do? Well, we need to come up with an equation, right? And what you know from probability distribution tables is if you add up the probabilities, they need to be summing to 1. So now we have this. Cosine theta plus 2 cosine 2 theta equals 1. Headshot. Thanks for following. And then what we need to do is essentially have a cosine. So we are going to use a double angle identity on this. I'm gonna need more room. Tanene, thanks. So next up, we use that double angle identity. And then, essentially, we have 4 cosine squared theta plus cosine theta minus 2 is equal to 1. And then if we just bring the 1 over, or actually let's bring the 2 over. Should we? No, we gotta bring the 1 over. We bring the 1 over, so this becomes 3 equals 0. And then now we switch from probability, knowing that this equals 1, to trigonometry using double angle identities, and now we switch to quadratics, because this is a quadratic for cosine that we're trying to solve for. So we can factor this. And then you know that the last two terms, or the last term in each factor needs to be 1 and 3, because they need to multiply to make 3, negative 3. And then how is this going to factor out? I think it's 4 cosine and regular cosine. And then I think it's minus, no, plus and then minus. So we factored it, and then show that cosine equals 3 over 4. That comes from this factor right here, right? And this is why this question's worth 6 marks. You also have this one, which says that cosine theta needs to be equal to negative 1. However, this is not a possibility because... Actually, it could be a possibility. Oh, no, it can't. So this can't be a possibility because remember, this cosine theta represented a probability. Yeah, right here, right? And you can't have negative probability. So it's just 3 over 4. Okay, then what's next? Given that tan is also positive, find tan theta. So if cosine is positive and tan is positive, then you know your angle is an acute angle. And it needs to be in the first quadrant. And then given what you know, right? Cosine's 3 over 4, so that means that the adjacent side over the hypotenuse is 3 over 4. So we can build a right triangle like this. If we want to find tan, then we need to get the opposite side and divide it by the adjacent side. So we just need to do a little bit of Pythagoras. So what's 16 minus 9? 7? So this is root 7 from Pythagoras. So tan is positive root 7 over 3. And then what's next? Now let y be the reciprocal of cosine. What the hell is going on? So the graph of y between x equals theta and x equals pi over 4 is rotated 360 degrees around the x-axis. Find the volume of the solid. So this is no longer part of the curriculum, but this is essentially calculus. So this is a pretty crazy final question. But we're not going to do this one because, again, no longer part of the curriculum. But man, this is a wild question to end on. Rotate is never could be me. Don't worry about it. As long as you're not in HL, you'll be fine. You don't have to worry about this rotation stuff. Okay, so see, assume evidence of knowing adding up probabilities needs to be 1, so now it equals 1. Use double angle, you have this quadratic, and then you can factor it, and then you reject cosine being negative for the correct reason, and then that's because cosine is a probability, so you can't have a negative. Thus, you get 3 over 4. Notice, you have to give a reason. It says right here, don't give a mark if you don't give a reason for rejection. So you do need to state specifically, this can't be a thing because it's a probability. Is that always the case? Probably. Oftentimes when you reject answers, you need to explain why you're rejecting them. Because this is a perfectly valid solution for this equation. But because this equation now has context and it's in terms of probability, well, that's why you reject it. Okay, valid approach. Sketching a right triangle with sides 3 and 4. So that's what we did right here, right? And then you end up with tan root 7 over 3. So there you go. And then you see you need to do calculus and do an integral for the final part. But we're not going there. Nice. So overall, pretty well done. I don't know, I guess I didn't get 100% because of this question. I messed up because I put +6 instead of -6. But my method was correct, right? All of my math was correct in what I was supposed to do. So overall, pretty good. And out of the questions that I did do, this one was definitely the hardest one. And this paper should have taken you so this paper should have taken you 1.5 hours, and then it has 90 marks. So in other words, where's my calculator? So how many minutes per marks is that then? So that's 1 minute a mark. That's crazy. So they don't even give you like buffer time. A mark a minute. And then let's see. However, we did skip questions, so we skipped this one, 17, so take off 17 minutes. And then we skip the final one, which is 6, so take off 23 minutes. So this should have taken you, the questions that I did should have taken you a little over an hour and 7 minutes. However, that's not the new IB time, because the new IB time is 80 marks in 90 minutes. So you actually get slightly more time with the new curriculum. It's not that much more, but yeah, you do get, I think, like 1.33 hours, or you get 1 minute and like 1/3. Yeah, for next week's exam. Both should be, I think, out of 80, and they're both worth 90, or they're both worth 80, but they're 90 minutes each. So yeah, not a minute a mark. How much is that then? 90 divided by 80. Yeah. So take away 1, multiply by 60. Okay. You get 1 minute and 7.5 seconds per mark. Yeah, I hope you guys will be okay. But, for me, I finished this paper in 57 minutes. At least the ones that I could do. Not bad. Okay. And it's been less than an hour, so I might just play, let's just play Garlic Phone for like half an hour. And then I'll call it a short stream today. And I'll stream on Sunday. I don't know. And then Thursday. Wait, Snake Star, when's the exam? Thursday, Friday? Thursday, Friday, right? So I guess this Sunday is dedicated to you. So let me know, I guess in Discord or anything, if there's anything you want me to go over before your paper on Thursday. And then you're gonna have your paper, and then let me know on Thursday's stream anything you also felt you were lacking to get ready for Friday's stream. Am I streaming with my students? Yes and no. Some of them are my students. Snake Star is not my student. He's from a different province than where I live. Okay, so screw this stuff. What was it? Garlic phone, Gardic phone, right? Okay. Custom settings. The time was too slow. We're gonna do normal. And then I'm gonna paste the invite in chat. There you go. Come join. Let's play for half an hour. Okay, there's Serpent. Where's Vincent? I don't know who Marlo is, but sure. Okay, there's Snake. Is this it? Just 4 people? How long should we wait? Okay, while we're waiting for more people, if more people are interested, let me rant to you, Snake Star, about my kids and their recent test. So I gave them a little mini test on statistics and probability, and I dug through years and years of questions that IB has given them, and I tried to give them reasonable ones. And one of the questions asked them to make me a bar graph, and they couldn't do it. Isn't that so sad? Well, because it asked them to, it was a cumulative frequency table, and it asked them to make a histogram. And then it gave them a grid. And the grid wasn't like a square grid, it was like a rectangular grid. So it was very obvious that you needed to make a bar graph. And then the question before that said, what is the modal class? The modal class. I literally walked down a row in my classroom, and like 4 students in a row, as I walked by them, they all raised their hand and asked me, what is a modal class? How many people didn't make a bar graph? I don't know. Too many people. So disappointed. Okay, let's get this started. Oh, start a story. I guess you guys shouldn't see this, right? Turn this off. During a test? Yeah. The audacity. I mean, like, you can probably tell from my personality, but what am I supposed to do? Teacher slaps a student. Oh, man. I don't know what to draw, I guess. Here's the hand. And I guess I'll draw some speed lines. And then although, how do I signal that it's a student? Yeah. Did we all just write the same story? What is a histogram? Walking to school? I guess they'll have green pants. This is Garlic Phone. You should have joined. It's like it's a Pictionary or like whatever it's called. Join the next one. You know telephone? It's Pictionary telephone. Okay, I chose fast timer, but it's still so slow. Yeah, Quadratic phone. Join in. Next game. Huh? Money? Is it just money? I love lots of money. That cash. That dough. Them bands. Okay, so let's see how it went. So this was my story. Model F. Moron gone in F. Oh no. Dumb kid is excited. What's a histogram? Oh, did I say what's a histogram? Wow. Oh, what is a histogram? Oh, nice. Histogram. Good, now you guys know what a histogram is. Teacher slash student. What's it? No, it's not. What's a histogram? It's quadratic? Are you? I know you're just trolling, Snake. Walking home one day from school. Oh, walking home? Why would you say walking to school? The person's clearly pointing the other direction. I'm ready for my test. Nah. Not sure what's going on at the moment. Oh, ATM. Oh. Money. And then this is where I said what I said. I love lots of money. Okay. Join in, join in, join in. Why'd you people leave? Where's Marlowe? That person left. Now I have horse. Should we try a different one? Link it again? Oh, Jenny's here too. Snake is here? Wait, why do I have double snake? Should I kick this one? Does this one not exist? You should mute the stream? I mean, depends. Oh wow, so many people now. Okay, let's see. What sounds good? I want fast. Okay, start. Okay, make up your own story. And then the next person's gonna draw it. Wow, the timer is actually fast now. Alright, see you later, headshot. Not cool. Me in a maid outfit? This is rude. I don't even know what it looks like. Something like this? Oops. Uh-oh. I gotta go fast, gotta go fast. Okay, I think that's all I can do. I like the pink hair. Begging for a B. What? I hate math. I hate it. Ah. Why are these all the same? What the hell is this? Oops. What do I want to do? Sure. Just hit 10K? What does that mean? What do you mean you just hit 10K? Okay, let's see how everyone did. Oh, 10K channel points, nice. Nice, good drawing, good drawing. Fat guy wants chicken nuggets, but they're out of reach. Empty? Come on, Serpent. Empty? My nugs. Nuggets. Oh, nice. Slanders for not knowing math. Yeah. Seconds before? What do you mean seconds before? Okay, good try, Miskoman. Why is it black? IB's killing me. What am I doing with my life? What is math crisis? Uh-oh, everything's on fire. I hate math. Oh, this is what I do. X equals 30. Why would you write Y when it said X? Flight to Egypt. Oh, okay. Oh, that's what it's supposed to be. Oh yeah, Serpent's Wi-Fi died. So I think if it dies, then it just passes on to the next person. Nice. Yeah, plane flying over pyramids. Oh, at nighttime. Nice touches. A man throws up a cheese? I don't know which one this one is. Did I draw this one? Huh? Having an itchy? An itchy what? Oh, that's what that's supposed to be? Oh my god. He was just scratching his arm? Stressing for B. I want B, please. Begging for B. Got a map. He told the truth, but they did not listen. Oh, you were the one that did this? At the gym? In what way is this me at the gym? Nice. Oh, that's almost the same drawing. You pumping iron? Yeah, right. Oh, I get it. Okay, are we continuing? Who is horse? I don't know who horse is. Were they AFK? We can have one more time. Let's go again. Oh, start a story. I don't know what to do this time. Uh-oh, I'm running out of time. Butterfly smoking a cig. You want to play? Next time. Huh? Oh. When's the next time? When this is over. Like next game. Dude blowing air into balloon. Balloon is full of air. Mm. Yeah, next game. Can y'all think of better stories? Money, please. I want cheese and stuff. No. Poor boy asks for money when grocery shopping. Oh shoot, I didn't finish. My bad. Student doing math test, most likely an IB student. Why do you guys keep doing this? Oh yeah, how'd the Mandarin exam go? Bad? Really? What the hell is this supposed to be? Oh, that sucks. Lizard got a C. Oh no. Okay, let's see how it is. Eating burger. Oh, nice burger. Person holding up burger with mouth wide open about to gnaw. That's a buff arm. Pac-Man eats... Pac-Man doesn't have a body. Beret? Pac-Man eating beret. Oh, at least it got through. What is beret? Lizard drinks coffee. Oh no. Oh, how'd you get coffee from this? That's not coffee. Salamander getting a C. How's this a C? Oh, cash. What the heck? Lizard got a C. Oh no. Who's that guy that's jumping? What is this? Who is that guy? What? S? The capital letter S in quotation marks? Why'd you draw a butterfly smoking a cig? Yeah, butterfly shouldn't be smoking. Thick pickle is getting a hit from a cig. Oh no. Math teacher runs out of classroom on students crying. You're distracted? Then don't be distracted. Bye, I'm gone. Run, there's an earthquake. That's not a good earthquake. Blowing a red balloon. Oh, that's pretty good. Nice. Nice. Sucking. Oh, come on, Tofu. Oh, okay, not bad drawing, I guess. Buying a visa. I mean, I guess. Money for cheese and stuff. Oh, that's what this one was. I ran out of time. Poor boy asked for money when grocery. Poor person begs no frills shopper for food. Nice. I don't know what is math. Help me, please. Why is 20 times 50 10? Student doing math, most likely an IB student. Idiot taking IB exam. Oh, nice. IB exam. Should have done AP. Oh, shots fired. Okay. So, for those that want to join, here is the link. Do you guys want to try this one? Right, only at the beginning and at the end. So every turn, everyone just draws the picture, and then the last person tries to guess what it should be. Let's just try this one out. Strawberry. Anyone else? Someone just left. Yeah, it should be beret. Okay, time to start my story. Who's point? Okay, is this RGBTs? No one's gonna get this. Okay, memorize the drawing. Okay. Oh shoot, I forgot. I have to draw this. Huh? Oh, now I describe this. Huh? Ugh, I couldn't type fast enough. Okay, let's see how this went. Stupid fish crawled out of water. Now I have to go to work. Travail? Yeah, why are there so many sharks? We have the same amount of time. Why do the drawings get progressively worse? Shark attacks, and then shark eats me. Lizard eating burger. Nice. a shark comes in here. Because this was the last drawing I did. Why is your burger pink? Why you gotta do this? Green slug wants burger, but blue shark is gonna eat him. Help, I'm dying in a river. Please save me, Spider-Man. Oh, Spider-Man! Oh, that's who this was. Oh, that's what that S means. And that's why he's red. Okay. And here comes the shark again. Now it just looks like he's on a surfboard. And it changed to a table. Is that a life floaty? Just wants to be friends. See? Saving a friend. Y'all butchered it. Scared of ants. Okay, I think this one's good, right? Unless I got it early. Give us you. Visibly scared. Nice. Why you gotta have sharks all the time? Shark eats person on the table. Person on ladder drops a painting and it cracks in half. Oh, not bad. And then of course the shark comes in. How did this turn into a door? How is there a shark everywhere? Skydiving goes terribly wrong. Oh, okay, I know what this is. You see, why did you draw the person falling upward? I was so confused. Oh yeah, nice. I quit my job. This is exactly what will happen if this comes true. I'm leaving you the moment I get money. This is also a possibility. Screw you, RGBT. Taurus is a donut shape. Oh, now it's gonna turn into like someone thinking about pizza. basketball? Mad at the basketball. Bubble tea lover dropping bubble tea. I have no idea what this drawing is. I don't know if I drew this one. But we all drew it, right? Where did this go wrong? Or did I just not participate in this one? Oh, it was this. And then this stupid shark comes. And then I was like, what the hell is this? And I was like, scorpion chair? Unbelievable. Don't derail stuff. Try this again. No more sharks. Please. Please stop this. don't know what I'm drawing. Kind of what happened? Why is it green? Okay, this is the last game. So, I hope... it'll be a good one. I like how the universal symbol for me is a stick guy with pink hair. Okay, so here we go. Let's see the results and then we'll call it a stream. I forgot what I said. Oh, Weed BO will not go streamer girl. What do you think BO means? Body odor. It went wrong at the beginning. Oh god. I like how there's a blue headband now. Kung Fu dude defeats guy with knife who thinks he's cool. Master Splinter takes your money and leaves. This was so hard to draw. You turned into a cat. Why is the world on fire? Why did it turn into me? Oh, now he's giving me money? Nice, thank you. What lot? Why did he turn into this person? Were you trying to say lottery? Me being terrible at basic math. The calc is disappointed. Again? Shaking my head. SMH. What does loat mean? Okay, these drawings are getting progressively worse. Why did he turn green? Why is it cucumber? Oh, this is where this is what happened. Pickle robs me with a knife. I could take on a pickle. Strawberry on fire in the night sky. Oh. Oh yeah, this is a pretty good drawing. But you should have seen what I was given. I was given this. That's a terrible drawing of a strawberry. Library? That's so stupid. Biology student dissects a cat. Oh, I know what this one is. Cool poo. Go poo. Pee? Why just pee? How do you run out of time to say what this is? I have to really go pee badly. Why he starts so quick? Need to pee. What is this symbol? Why are you running away from this person now? Okay, we brought it back here. But I thought, yeah, tummy ache, and then he had to go poo. Kill all sharks, I want them gone. Enough. And then of course, dead shark something. Reign of Terror ends. Yeah, we brought it back. Shark is no more. Reign of Shark ends here. Yes, it does. Yes, it does. Actually a shark this time. Screw you. Oh, nice. Revenge of the Shark? Oh, it comes back? Are you serious? A pizza eating a person. Idiot. Only an idiot would get eaten by a pizza. Oh, so that's what this was. I was confused. See, this is what I got. This is not a basketball. Stupid shark. I'm kicking you out. Ugh. Okay, we're gonna call it a stream. Yeah, take your BO out of here. Well, thanks for playing, everybody. And yeah, I'll see you guys on Sunday. Have a good weekend. Talk to you later.